A Zero fighter rolled to a stop at the edge of a muddy runway. Nothing appeared seriously wrong. The engine had survived another combat sortie. The wings were intact. Enemy fighters had never touched it. Yet it would never fly again. Somewhere hundreds of miles away, buried beneath a warehouse, hidden under a rice mill, or locked inside an isolated supply dump, sat a single replacement part. No pilot could change that. And before the Pacific War was over, thousands of Japanese aircraft would be defeated not in the sky, but on the ground, by a logistical system that had quietly begun collapsing long before anyone admitted it. At the beginning of 1942, almost no one inside the Imperial Japanese military believed such a thing was possible. Victory seemed effortless. Within 4 astonishing months, Japanese forces had overrun airfields stretching from Malaya through the Dutch East Indies, Burma, and the Philippines. Nearly 3,000 miles of territory had fallen with breathtaking speed. Every captured airstrip appeared to promise another leap forward. Pilots arriving at newly seized bases found fuel waiting in storage tanks. Spare parts remained stacked inside abandoned hangars. Maintenance schedules still looked almost civilized. A Mitsubishi A6M Zero could be pulled into an overhaul bay every 150 flying hours, stripped apart, inspected, rebuilt, and returned to service almost exactly as planners intended before the war. From the cockpit, the machine looked perfect. From headquarters, the system already contained cracks no pilot could see. Japan did not possess one air force. It possessed 2. The Imperial Japanese Army and the Imperial Japanese Navy operated almost as rival organizations sharing the same empire. Their aircraft used different electrical systems. Their radios were incompatible. Maintenance manuals rarely matched. Training schools answered to different commands. Even spare parts often belonged only to one service. A mechanic qualified to repair one aircraft might be unable to repair another parked only meters away. The division reflected more than bureaucracy. It reflected distrust. Neither service wanted to depend upon the other. As long as victories came quickly, the inefficiency remained hidden. Rapid conquest disguised structural weakness. Maintenance units frequently arrived weeks after combat squadrons. Pilots often serviced their own aircraft between missions because trained technicians had not yet reached the front. Few complained. Everyone assumed the delays were temporary. Then Guadalcanal changed everything. When American Marines seized the unfinished airfield that became Henderson Field in August 1942, Japan suddenly faced a campaign it had never planned to fight. Instead of advancing across prepared bases, aircraft now operated at the very edge of supply lines that scarcely existed. The contrast became painfully obvious. In the entire first 10 months of war, Japanese naval engineers completed only one significant forward airfield beyond their original network, a rough strip at Bun. Construction dragged through endless tropical rain. Mud swallowed equipment. Drainage remained poor. Several of the first heroes assigned their word, imaged simply landing on the unfinished surface. On especially wet days, aircraft were lost without a single American fighter appearing overhead. Nature itself became an enemy. At Rabaul, conditions were scarcely better. There were few tractors to tow aircraft. Ground crews pushed fighters across the airfield by hand. Fuel arrived inside heavy steel drums. Instead of specialized refueling trucks, mechanics pumped gasoline manually, one aircraft at a time. Hours disappeared performing work that modern logistics solved in minutes. The tropical climate quietly attacked everything else. Humidity crept inside electrical systems. Metal corroded beneath fresh paint. Lubricants evaporated. Mold invaded delicate instruments. Every repair demanded parts already becoming scarce. Every delay kept another aircraft grounded. Japanese pilots noticed the exhaustion long before senior headquarters fully understood it. One naval aviator stationed at Bun wrote about mechanics dragging themselves across muddy runways after sunset simply to push aircraft beneath camouflage before collapsing into sleep. They dreamed, he wrote, about the tractors American airfields seemed to possess in endless numbers. They knew those tractors would never arrive. The mathematics became brutal. At Rabaul, records from the 23rd Airflow Tilla revealed that enemy action destroyed surprisingly few aircraft. Landing accidents, poor runways, and ordinary mechanical wear accounted for far more losses. Of 80-8 aircraft written off during one period, only 18 fell primarily to enemy attack. The rest succumbed to the system itself. The battlefield had quietly expanded. It no longer ended where bullets stopped flying. Inside Tokyo, another decision compounded the problem. Aircraft production exploded. Nearly 90 basic aircraft types entered production across the Army and Navy, followed by well over 100 variants. Every new design demanded unique spare parts. Different wiring, different mounts, different training. Standardization disappeared beneath overwhelming variety. Mechanics became specialists trapped inside increasingly narrow expertise. One technician might understand a zero completely yet and helpless before another aircraft parked beside it. Radio equipment became another casualty. Replacement sets proved unreliable and scarce. Some pilots eventually removed radios entirely to reduce weight rather than carry equipment unlikely to function during combat anyway. Every compromise made sense individually. Together, they slowly dismantled operational effectiveness. The greatest shortage, however, was not machines. It was people. Japan trained magnificent pilots before the war, but technicians received far less attention. The assumption seemed logical. Pilots won battles. Mechanics merely supported them. As combat intensified during 1943, experienced flight instructors left training schools and returned to operational squadrons desperately needing veterans. Their replacements possessed far less experience. Young pilots graduated faster. They also graduated less prepared. Saburo Sakai later described watching training compressed from years into months. American General George Kenney noticed the same decline from the opposite side of the front. The skilled Japanese airmen who had dominated early campaigns were gradually disappearing. Statistics concealed the tragedy. Japan produced almost enough new pilots to replace losses numerically. But numbers ignored experience. Every veteran lost became another novice gained. The force retained similar size. While Japan struggled to replace irreplaceable men, the United States invested elsewhere. Not primarily in pilots, in mechanics. Hundreds of thousands of them. Every combat pilot stood behind an enormous network of technicians, armorers, electricians, radio specialists, inspectors, welders, sheet-metal workers, and engine experts. Many more ensured he could fly again tomorrow. Training accelerated dramatically. Mechanics who once required 30-8 weeks completed courses in 16. Mobile schools traveled directly to combat units carrying cutaway engines, specialized tools, and instructors. Knowledge moved toward the battlefield, instead of waiting for soldiers to travel backward. At a Beatwentanai base in the Mariana Islands, one bomber belonged not to one mechanic but to an entire team. Crew chief, assistant crew chief, engine specialists, radio experts, armament crews, camera repairmen. Every system had someone responsible. No exhausted individual tried doing everything. The organization itself generated reliability. The American maintenance network resembled an assembly line stretching across an ocean. Routine inspections remained with squadron crews. Larger repairs moved automatically to group workshops. Major structural damage traveled farther still to permanent depots. Eventually, even floating repair ships sailed close behind advancing forces. Every damaged aircraft already had somewhere to go before it even broke. That certainty mattered. And time determined whether airplanes fought or merely waited. The American system was far from perfect. Shortages existed. Truck drivers occasionally learned aircraft repair simply because qualified mechanics remained unavailable. Ground crews worked exhausting schedules. Authorized manpower often exceeded actual strength. But shortages occurred inside a functioning system. Japan increasingly faced shortages without one. By 1944, the difference no longer appeared in isolated incidents. It defined the air war itself. Aircraft survived combat only to remain grounded indefinitely awaiting one missing component. Pilots walked past perfectly repairable fighters every morning. They knew somewhere another base probably possessed the required part. No mechanism existed to connect them. The machine waited. So did the pilot. Eventually neither returned to combat. The investigators kept walking. Every warehouse they opened answered one question while raising another. How could an air force surrounded by aircrafts still be losing control of the sky? Inside abandoned hangars at Clark Field, mechanics' benches stood exactly where their owners had left them. Engine hoists remained suspended over empty concrete. Tool cabinets still held carefully arranged wrenches. Aircraft logbooks lay open to maintenance entries that simply stopped in mid-sentence as bombing raids and retreat overtook the base. Nothing suggested laziness. Nothing suggested incompetence. Instead, every room pointed toward a system that had gradually become impossible to sustain. One revetment sheltered the Zero awaiting a replacement magneto. Another contained a bomber whose engines had already been removed. Elsewhere sat aircraft that needed nothing more complicated than hydraulic seals or electrical switches. The missing pieces existed somewhere. The men capable of fitting them often existed somewhere else. But war had stretched every connection between them until the network itself began breaking apart. For Japanese mechanics, the enemy was no longer only American aircraft. It was distance, confusion, paperwork, fuel shortages, bomb damage, and time. Every morning became an exercise in impossible prioritizations. Which airplane deserved the last usable spark plugs? Which engine should receive the final shipment of lubricating oil? Which pilot should be told his aircraft would not fly today because another squadron's machine had been judged slightly more important? These decisions rarely appeared in combat reports. Yet they determined which aircraft reached the battlefield long before pilots ever met one another in the air. American bombing only accelerated the collapse. Concentrated workshops invited destruction. But survival carried its own hidden cost. An aircraft needing work no longer rolled a few hundred yards across an airfield. Instead, requests traveled between hidden depots connected by damaged roads, unreliable telephones, handwritten notes, and exhausted truck drivers trying to avoid fighter patrols overhead. Every additional mile became another opportunity for something to disappear. A shipment failed to arrive. A bridge had been destroyed. Fuel for transport never reached the trucks. Someone buried replacement parts for safety, then died before revealing where. Slowly, aircraft stopped becoming machines. They became puzzles with missing pieces. American logistics faced enormous distances as well. The Pacific was larger than any planner had imagined. Thousands of miles separated factories in California from airstrips carved into coral islands. Engines still failed. Parts still wore out. But the American response increasingly relied on predictability rather than improvisation. If a squadron reported recurring failures, replacement components centered an established pipeline. If damage exceeded local repair capability, specialized maintenance echelons already knew where the aircraft belonged next. No commander needed to invent a solution every week. The system itself absorbed the problem. That difference grew larger every month. By late 1944, American mechanics expected aircraft to return to service. Japanese mechanics increasingly hoped they simply would not deteriorate further. Hope gradually replaced planning. And hope proved impossible to schedule. The floating repair fleet illustrated that contrast better than almost anything else. When the ivory-soaked ships anchored near newly captured islands, they effectively brought an industrial district directly behind the front. Aircraft arrived damaged. Specialists inspected them. Machine shops manufactured replacement components when originals were unavailable. Electrical technicians repaired radios. Instrument experts recalibrated flight equipment. Propeller shops restored blades bent during rough landings. Within days, aircraft often returned to operational squadrons without ever traveling thousands of miles back to permanent depots. Distance had been turned into organization. The Japanese possessed talented mechanics capable of extraordinary improvisation. Many kept aircraft flying through methods that astonished Allied investigators after the war. Damaged components were welded repeatedly. Engines considered beyond repair elsewhere continued operating through sheer persistence. But improvisation is not the same as capacity. A gifted mechanic can rescue one aircraft. He cannot sustain an entire air force. The psychological burden became almost unbearable. Pilots naturally received public attention. They flew combat missions. They earned decorations. They became newspaper stories. Ground crews watched them depart every morning knowing that every successful mission depended partly upon invisible work completed through the previous night. Few photographs captured those men sleeping beside aircraft because there were not enough barracks. Few histories remembered the mechanics who rebuilt landing gear under tropical rain or replaced engines while bombers circled overhead. Yet without them, the pilots never left the ground. Japanese diaries reveal growing frustration inside maintenance units. Mechanics described endless shortages rather than dramatic defeats. They complained about missing bearings, contaminated fuel, engines arriving without manuals, aircraft transferred between services that used incompatible equipment. The entries sound mundane. That is precisely why they matter. Wars rarely collapse through one spectacular failure. They erode through thousands of ordinary problems that no longer have ordinary solutions. Meanwhile, American production increasingly erased mistakes almost as quickly as they occurred. A damaged aircraft represented work. A destroyed aircraft represented replacement. Factories continued delivering both machines and spare parts at rates Japan simply could not approach. The industrial gap mattered. An organization multiplied its effect. An engine sitting inside a warehouse contributes nothing. The same engine installed on an aircraft within 20-4 hours changes tomorrow's battle. Logistics transformed production into combat power. Without logistics, production remained inventory. By early 1945, Japanese commanders faced choices that would have seemed unimaginable 3 years earlier. Aircraft sometimes remained grounded to preserve scarce fuel. Others flew despite overdue maintenance, because no alternatives existed. Replacement engines were reserved for selected units, while equally important squadrons waited indefinitely. Training suffered the same fate. Every engine used preparing new pilots consumed resources unavailable to combat formations. Every instructor retained at flight school represented one fewer experienced pilot defending the homeland. Every decision solved one problem by creating another. There were no painless options left. When Allied investigators later interviewed surviving Japanese officers, many emphasized courage, sacrifice, and determination. Those qualities unquestionably existed. But courage could not manufacture bearings. Sacrifice could not standardize electrical systems. Determination could not shorten shipping routes across submarine minus-infested seas. Eventually, even the bravest air force becomes limited by mathematics. Aircraft unavailable for maintenance cannot intercept bombers. Pilots lacking training cannot replace veterans indefinitely. Engines without replacement parts eventually become silent regardless of the skill of the men who once flew them. Looking across Clark Field after its capture, American personnel saw more than abandoned airplanes. They saw an entire logistical philosophy frozen in place. Replacement engines waited inside and opened crates. Tools remained carefully preserved. Individual pieces of the system had survived. The system connecting them had not. A single carburetor separated one fighter from flight. Somewhere nearby, buried beneath Earth for protection, that carburetor almost certainly still existed. It simply never reached the aircraft that needed it. That image captures the final years of Japan's air war more clearly than any casualty chart. Not empty factories. Not total industrial destruction. Instead, usable resources stranded by an organization no longer capable of bringing them together at the right place in the right time. When historians examine why American air superiority became overwhelming in 1944 and 1945, aerial victories naturally attract attention. Dogfights are dramatic. Bombing missions dominate photographs. Ace pilots become legends. Yet beneath every combat story stood another contest fought with shipping manifests, maintenance schedules, standardized components, training schools, repair ships, and exhausted mechanics whose names rarely appeared in official communiques. One side steadily expanded that invisible network. The other slowly watched its own unravel. By the time aircraft met in the skies above the Philippines, much of the outcome had already been decided hundreds or even thousands of miles away. Not by the man holding the control stick, but by the mechanic waiting for a missing part that never arrived. Long after the gunfire around Clark Field faded, investigators continued cataloging engines, propellers, radios, carburetors, crates, and tools scattered across warehouses, villages, and concealed storage sites. Each item represented work that had been started but never completed, potential that had never become capability, aircraft that almost flew, missions that almost happened, pilots who waited beside machines that looked ready for war until they finally understood they would never leave the ground. In the Pacific, victory certainly belonged to those who built better aircraft. But just as often, it belonged to those who built the better system for keeping those aircraft alive after the factory doors closed.